Alright, so I'm going to go over all these in a video just in case. This will be like the post-test review that we would have. So in case you're wondering why you missed certain problems. Alright, let's do that. Okay, so first one, not a geometric series, so we'll have to do ratio test. And I'm going to kind of rewrite this. So we'll say this is okay, the 5 to the n plus 1, you could rewrite, this, just the 5 to the n plus 1 is 5 times 5 to the n, and then the x plus 4 to the n and the 5 to the n, you can combine those into like a fraction. And if you do that, so this n and this 5 will stay in the bottom. It's like 1 over 5n maybe. And then you can kind of make one big fraction, x plus 5 over, or x plus 4 over 5 to the n, like that. Okay, and you could even pull out the 1/5 also if you want, but doesn't matter, I think. Okay, so now we'll do ratio test. Yeah, okay. Alright, so this will be and then it's going to be, this will be to the n plus 1, and so you can separate those. People are pretty good at that, I think. Like that. Okay, and then now we'll times it by a reciprocal key. So I'm just going to put bottom, and then the 5n goes in the top. Alright, looks a little messy right now, but it'll clean up a lot. Okay, this 5, oops, that's all with that 5, and I think that's it. Okay, so now we can say, actually, we'll pull out, now we'll pull this out. Anything that doesn't have an n in it, we'll pull out. And we just remember we got to keep it inside the absolute value. And then the only thing we're left with is this n and that n plus 1. Okay, this whole limit goes to 1. Just left with the rest. Okay, and then we know how to rewrite this. Multiply everything by 5. Subtract 4 from everything. Okay, and just so we can see, if we look at the answer choices, we can see it has to be A. So we don't even have to test the answer choices for this. Yeah, just to see, if we plugged in -9 into here, we'd end up with an alternating series that converges based on the alternating series test. And if you plugged in a 1 into here, you get 1 over 5n, and that diverges because it's basically a p-series, where p is 1, or harmonic series. Okay, but we don't need to, so I won't. That's A. Okay, next one. Let f be the function with f of 0 equals 0, and derivative that, which of the following is the Maclaurin series for f? Okay. You know, we've got the kind of zeroth derivative at 0. We've got the first derivative that we can get at 0, and we could just keep taking derivative of this if we want, and then plugging in 0, and we'll just get these, you know, terms. Let's see if we can figure this out just from the first derivative even. You know, so it'd be the first derivative would get multiplied by x, first derivative at 0. And so, yeah, so the first derivative, you know, if we, you know, because these terms, just to kind of re-emphasize this, you know, it's going to be f at 0 plus f prime at 0 times x plus f double prime at 0 times x to the, or times x squared, oops, all over 2 factorial, you know, and just gonna keep going from there. Third derivative at 0, x to the third, 3, you know. Okay, and so, you know, so we've already got the first term is 0, f of 0 is 0. We could figure out this at 0 times x is just x, so we know it's either a or b. Maybe it's better, we could just take the derivative, just one more derivative, and see if it's positive or negative, and that'll determine which one it is. So, yeah, better just take derivative of this. Okay, so I'm going to rewrite it. That. And we can see when we take second derivative, it's going to be negative. That's from a chain rule, 7x to the 6. Like this. And then if you plug in 0 into this, oh, no, that's positive, okay. Oh, wait. Plug in 0. Oh, you get 0. Okay. So this, oh, that makes sense, because these are like to the 8th power. Okay. Okay, so we realize now we don't want to take 8 derivatives of this. So let's do this a better way then. So the other way is going to be better then. Okay, so let's compare this to a geometric series, and this is almost one anyways. Okay, and then we'll plug in plug in x to the 7th, negative x to the 7th, and for both. So plugging in negative x to the 7th. Get that. And you'll end up getting negative 1 to the k times 7x to the k. What am I doing? X to the 7th to the k, which is really x to the 7k. Wait, is that right? What am I doing? Yeah, okay. Okay, so yeah, so now we can see, this is a little bit better now. So now we can see this is f prime, right? Okay, so now we see if we integrate here and integrate here, like this. And actually, before we even integrate, I'm gonna, well, integrate this. This is just f of x. And then this is going to be like the we'll do the integral, and I'll write out the first several terms of this. So like the first term, if you plug in 0, you get 0, and that makes sense, f of 0, 0. If you plug in 1, you get negative 1. Key. And that's negative 1, sorry. Wait, what am I doing? Oh yeah, negative, what am I doing? Negative x to the 7th. X to the 7th, okay. And then we'll get plus, when we plug in 2, you get x to the 14th. Plug in 3, you get negative x to the 21st. Okay, and I keep going like that. And now we can just kind of integrate these. And so this is going to be negative x. Wait. Oh, if you plug in 0, you get 1, so there should be a 1 here. What am I doing? Alright. Anyways, so this will be x minus x to the 8th over 8 plus x to the 15th over 15 minus x to the 22nd over 22. Alright, and now we can see that that's A. Okay, so this one I thought was a kind of a tricky one. So it's got like, we can kind of rewrite this. I'm going to rewrite this as f of x equals cosine x times 1 over 1 minus x. And so we can see if we could figure out, so I'm going to call g of x cosine x maybe, and then maybe h of x 1 over 1 minus x. Okay, so we know this 1 over 1 minus x is this summation x to the k. And then we'll find the one for cosine, and then we'll multiply. But you know, in general, you can't really multiply series because you'll have to FOIL. I mean, you can, but it's complicated and it's not typical, you know. But we'll only have to do the first 2 terms, maybe 3 terms, I don't know. First 2 terms. And so we'll see how this works. Okay, so let's find the Taylor polynomial for cosine. So we'll say g prime negative sine, g double prime negative cosine. That's good enough. So we'll do, you know, so now we're going to do g of 0 plus g prime of 0 times x plus g double prime at 0, x squared over 2 factorial. And so this g prime of 0 is 1, g double prime at 0 is 0, and then the last one, this is g double prime at 0 is negative 1, and so this will be negative x squared over 2. And then we could keep going, but this is basically, this is cosine x. And if you think about it, the other one, 1 over 1 minus x, is 1 plus x squared plus like that, right? And then we can just multiply these. And think about when you FOIL, you're basically doing like all these terms you'll times by 1, and then all these terms you'll times by x, and then all these terms times by x squared. So you can't do that since there's an infinite number, but we can just do it. We're only looking for the second degree polynomial, so we're only looking for terms that the highest exponent is 2. So think about, we can just take these first 2 terms, multiply it by 1, take these first two terms, multiply by x, first two terms, multiply by x squared, and then only take the terms that are degree 2 or lower. So we'll do that now. So we'll do these terms times x, or times 1, which is 1 minus x squared over 2, plus and then we don't have to do this times x, so we'll just do 1 times x, and then 1 times x squared. And that's it. And so if we do any more foiling, then we're going to get terms that are higher than degree 2, so they won't contribute to this anyway. So, and then we'll just simplify it. And that'll be it. Okay, so that's C. Okay, this next one, let f be a function defined by that, which of the following is a Maclaurin series for f prime. Okay, so this should be a quick one. So, oops, f of x equals okay, if we take derivative, we know we're going to get an x, a k times x to the k minus 1. It's going to be to infinity. Okay, we can kind of tell. We'd have to, if the answer choices had different n values, we'd have to, and I use k, but same thing. Then we'd have to figure it out, but we know it's going to be, if we take derivative, it's going to be b. That's, yeah. Yeah, it's the only one that has that. Yeah, it definitely won't be an alternating series like C or D. And that's going to be it. Yeah. Okay, so they say this power series converges at 5, which of the following must be true. Okay, so this is at least how I think about these. Let's say you had a number line. Okay, we know the center is going to be 3. Whatever makes this 0, that'll be the center. Okay, we know that it converges at 5. So we know the radius of convergence has to be at least 2. This radius of convergence could be a little farther, but it's at least 2. So here, we know what converges. I'll put all the stuff that converges in red. These converge, this converges, and then everything here converges. Okay, so that means the radius of convergence is at least 2, so it's got to be all these numbers to 1. Those have to also converge. Maybe not at 1, right? You could have one endpoint converge and the other not, right? But anything in between 1 and 5 has to converge. Okay, so when they say which of the following must be true, definitely don't know at 1. They could converge or not converge. Which one must be true? 0 here, this could converge or diverge. We don't know anything about what goes on at 1 or to the left, right? So these all could converge or might not converge. But we know it converges at 2. We don't know about 6 either, but we know it converges at 2. So that's got to be it. Okay, this next one, interval of convergence. Definitely, this is a geometric series, so we can rewrite this. At least the general term we can rewrite like that. Okay, since that's this is geometric, you know, something to the n, so we can just put this in between -1 and 1. We don't even have to do a ratio test. So this, and then multiply by 3, and then add 1. Okay, and since this is geometric, it does not it never converges at the endpoints, so we don't even have to test them. So we know this is going to be C. Okay, so this is not geometric, so we'll have to do ratio test. Okay, remember ratio test, forget about the alternating series part. And so this will be limit. Okay, so this will be x plus 3 over 2 times x plus to the n. And then times reciprocal. This less than 1. Okay, those cancel. Okay, pull out this term that doesn't have n in it. So this part goes to 1, so we're just left with this. And then we'll do that -1 to 1 thing. Okay, and then subtract 3 over 2 from everything. Okay, so we know it's either A, B, or C. Okay, so we have to test endpoints. Okay. Okay, so let's do when x is -5/2. Okay, so when x is -5/2, we look up here. This is -1 to the n times -1 to the n. That'll be -1 to the 2n, which means that'll always be just +1. And so that's if you plug in, so that means if you plug in -5/2, you really just get 1 over n. And we know that this diverges. Okay, so it can't equal -5 over 2. Do we know the answers yet? No, so that at least eliminated C, so it's either A or B, so we'll have to test the last one. Okay, if you plug in -1/2, this becomes 1 to the n, which is always 1, so we just ignore that. So this is really just that. Okay, and this is an alternating series, so we can do alternating series test, and this passes the alternating series test. You know, the 1 over n part goes to 0 as n goes to infinity and is always decreasing. So this one converges. By alternating series test. Okay. And the other one diverged, harmonic series, or P series, where P equals 1. Okay, so we know it does converge, so we include negative half. So we'll include it over here. So that'll be the answer, which is B. Is that right? B? Yeah. Okay, next one. Series converges to which of the following? Okay. Okay. So if we can eliminate some, we can eliminate cosine for sure. We won't have the exponent here be different than the factorial for cosine. So we can definitely eliminate that. And then I'm gonna try e to the negative x squared. See if that works. Yeah, so let's do that first. That one looks like the best kind of candidate. So we'll do e to the x. Let me do that here, because we might have to test more than one. So we'll do that, and then just we'll get the Maclaurin series for that. You know, since we can tell this is a Maclaurin series because it's not x minus anything or x plus anything. And so we'll do the Maclaurin series for this, and then plug in negative x squared for x. So okay, so Maclaurin series. Okay, so everything equals e to the x. So we know we're going to have, it's going to be 1, and then it's going to be plus, you know, all these derivatives are 1 when you plug in 0, so this is just 1 plus x squared over 2 factorial plus x squared over 3 factorial, right? And then if we plug in negative x squared into these, we get, so this is e to the x, so e to the negative x squared, 1, this will be minus x squared, plug in, and this will be plus, so even though we're plugging in negative x squared in for this x, it'll become positive once we square it, and that'll become an x to the 4th over 2 factorial, this will be minus, oh, that should be cubed. And then plugging in negative x squared, we'll get x to the 6th over 3 factorial, and I think that's what it was. If we compare them, yeah, okay, so it's got to be D for sure. Okay, so I got lucky. But yeah, just the other ones didn't make sense. I don't know. Okay, next one. Okay, which of the following is Maclaurin series for that? Okay, so I don't know if you remember, this is actually the derivative of 1 over 1 minus x. Right, so if you look at f of x equals 1 over x, the derivative, you can rewrite this as 1 minus x to the negative 1. So the derivative of that is you get a negative 1 here, but you also get a negative 1 from the chain rule, so those will cancel. So this will just be 1 minus x to the negative 2, which which is 1 over 1 minus x squared. Okay. Okay, so basically, this one, 1 over 1 minus x, is just this x to the k, right? And so if we take derivative, f prime, okay, take derivative, that's just, and actually let's write out the first term since they did it too. So this is 1 plus x squared plus blah blah blah. Okay, so now we know we'll take derivative. We need the derivative from this. Okay, now we know that's 1 over 1 minus x squared. And then now we'll just take derivative of all these terms. So that first term will be 0, but then the next one will be 1. It'll be 2x plus, and then this is, x cubed plus x to the 4th, 3x squared plus 4x cubed. Okay. So now we know this is C. Okay, so what's the sum of this series? Okay, so if you notice that this is 1, it's like this is 1 plus x squared over 2 factorial plus x to the n over n factorial. So that's this, but just with, so like if this was f of x, this would be f, the series, this series up here would be f of ln2. Okay, and then this series here, if you, we just did it in the previous one, is e to the x. And so this is really e to the ln of 2, which is just 2. And so that's just C. Okay, next one. Okay, let f be the function given by that. What's the coefficient of x cubed in the Taylor series for f about x equals 0? Okay, so we just want the cubed term. Okay, so we know it's going to be the third derivative at 0 times x cubed all over 3 factorial. So we really just have to get the third derivative at 0, and then the coefficient will be this whole thing, coefficient of x cubed. So just get the third derivative at 0 and divide it by 3 factorial. Okay, so I'm just going to keep taking derivatives. This is actually pretty easy. Okay, so now if you plug in 0 into this, that is negative 6 over 2 to the 4th, 16. And then just remember, we want to divide this by 3 factorial, so times that by 1/6. And so that'll be negative 1 over 16. And that's it. Okay, this should be a nice one. So if we've memorized, there's a bunch of these kind of in a row. So if we say, if we know that e to the x is x to the k over k factorial. Okay, and then we could rewrite out the first few terms, 1 plus x squared over 2 plus x cubed over, this is 2 factorial, 3 factorial, which is 6. We'll keep going. Okay, let me just plug in 3x into these. I'll skip over, just plug into the terms. 9x squared over 2 plus 27 x cubed over 6. And is that enough to tell what it is? The last one? Yeah. Okay, so that's got to be e. Next one, Maclaurin series for one of our, okay, we knew that. Which of the following is a power series expansion for that? Okay. Okay, so first we'll maybe plug in x squared for x, and so they have an expansion. So I'm gonna first expand this. So 1 over 1 minus x. If we expanded the series on the right, this would be 1 plus x squared. And so that means that 1 over 1 minus x squared, just plugging in x squared in for everything. And then just timesing both sides by, timesing everything by x squared. And then distribute the x squared to all these. That is D. Okay, so this next one, they're asking for the sum of this infinite series. Okay, so first off, we notice that it's some kind of series with pi over 2 plugged in. Okay, so let's rewrite those as x's first. This is like 1 minus, really like x squared over 3 factorial plus x to the 4th over 5 factorial minus over that. This will really be x, well, this will be negative 1 to the n times x to the 2n all over 2n plus 1 factorial. Okay. Alright, so here, let me think about what the best way to do this is. Okay, so the weird thing is that this exponent is always 1 less, right? These exponents are 1 less than the factorials. So do you get we could just multiply first, just multiply everything by x to get them to be the same? So first off, let's call this is f of x. This is our function that will eventually be, in some way plugging in pi over 2 into. But let's say you multiply everything by x. So x times f of x is x minus x cubed over So now at least we got those to match, which is kind of nice. Okay. And then, do you have some idea that this thing on the right here is like either sine or cosine? Because, you know, it's like the function will be 0, the first derivative will be 1, the second derivative will be 0, the third derivative will be -1, you know. The next derivative 0, next derivative positive 1. So that's kind of like sine or cosine. And so we can see it's going to be sine because, so this whole function is going to be the Maclaurin series for sine x. Because if we look at this, sine of 0 is 0. The derivative of sine, cosine 0, is 1. This is k equals 0, k equals 1, k equals 2. The negative sine of 0 is 0, k equals 3. Negative cosine 0 is -1. Okay, and so if we put this into the Maclaurin series, we know, we know the general term for the Maclaurin series is going to be fn of 0 times x to the k over k factorial. And so the first term will be just 0 because of that. When k equals 1, this part will be 1, and so we just get x. Okay, and that's how we got that. When k is 2, we just get 0. When k is 3, we'll get, this is -1, so this up here will be -1. And then when k is 3, this will be x cubed over 3 factorial, and so that's how we're going to get all these terms. Okay, so that means that this whole thing, which is x times f of x, that just equals, that whole thing equals sine x. That. Okay, that means our function is really sine x over x, and then now we can plug in pi over 2 into that one. Okay, and then sine of pi over 2 is 1, and this is 2 over pi. Okay, so that's how they got b. Okay, there might have been other ways to do this. You know, it's just the way I chose to do it. Okay, next one. Okay, so we'll get Maclaurin series for cosine, plug in x squared, and then times everything by x. Okay, so let's do that. Cosine x. So we know when we plug in 0, that'll be 1. We know 0, -1, 0, like that, right? Okay, so we know when we write this out, it'll be 1. And then here, so this is k equals 0. This next one is k equals 2. Okay, so this will be minus x squared over 2 factorial, and 1, k equals 4. This will be plus x to the 4th over 4 factorial. Okay, I think that's good enough. So now we'll plug in x squared for all these x's. So keep in mind this is cosine x. Okay, let me separate this. So that means cosine of x squared x to the 4th over 2 factorial. This really should be. And this will be x to, wait, what am I plugging in? X squared. So that'll be x to the 8th. Okay, and then times both sides by x. Times by x, times by x. Okay, and do we know, is that an answer choice now? Okay, so that is A. Next one, which of the following statements about that power series is true? And they all talk about convergence. Okay, so, you know, this definitely, if x is any number, this can't converge. You know, if it's any, like, I mean, really, this only converges when x is 0. Because, you know, if x is any other number, this thing just keeps getting, oh wait, sorry. Oh, actually, let's do it, sorry. It could be between -1 and 1. Okay, so let's do the ratio test. Okay, so we'll do, okay, so it'll be, okay, so this will really be x squared times x to the 2n. So if you plug in n plus 1, and for n, that'll be x to the 2n plus 2, and that's what that is. Okay, and this will be, okay, that has to be less than 1. Okay, those two cancel out completely. Do you remember this on the top? This is n plus 1 times n factorial. That's what this is. And so that cancels out. Just left with n plus 1. And then we could pull out the x squared. And we don't really need absolute value since it's squared, but that's what we'll typically do. And then this is just n plus 1. Okay. All right, so this will, you know, obviously this here is infinity, right? So if you think about it, if now we can see if x is, here, actually, let me think about this. Well, maybe I shouldn't have pulled out the x squared. Oh, actually, never mind. No, so this is going to go to infinity no matter what. This is going to go to infinity here. This whole this thing here. And then, you know, for, you know, x is really a constant. For some reason, I was thinking x could change, but x is some constant that is going to get multiplied by infinity, which is going to make this still infinity. Okay, so the only time that this converges is when x equals exactly 0, you know, and we can even see from the start, if x is 0 here, this is just 0 plus 0 plus 0 plus 0, and, you know, so that'll be 0, you know, converges to 0, which, you know, so this series only converges when x is 0. Okay, basically every series has to converge at least when x is 0, or when x is, you know, if you had x minus c, if this was x minus c to the 2n, you know, when x is c, that'll converge also. Okay, this is a free response. All right, so we basically did this one, but we had negative x squared, I think. Okay, so I'll just rewrite, since we've done this one came up a lot. So e to the x, so we know that this is from, actually I'm going to write these out, write these terms out. So this is going to be 1 plus x squared over 2 factorial plus x squared x cubed over 3 factorial. Okay, if we plug in negative 2x squared, we get 1 minus 2x squared, we get plus 2 squared x to the 4th over 2 factorial, and then we'll get plus 2 to the 3rd x to the 8th over 3 factorial. Oh, that'll be, oops, that'll be, wait, what am I doing? Oh, that should be a 6. What am I doing? This should be a 6, and this should be minus. Okay. And then now if we rewrite this as a series, because we need to write this as a series before we can find the interval of convergence, so that we can do ratio test. Okay, this will be k equals 0 to infinity. Okay, we know we're going to have a negative 1 to the k, since first term is positive. And then all these terms are going to be, you know, so this is like 2 to the 1, 2 to the 2, 2 to the 3. So this is 2 to the k. And then this is x to the 2k. And then this is all over k factorial. All right. Okay, so now let's do ratio test with this. Okay, this will be 2 times 2 to the k plus, okay, if that's k plus 1, that'll be like x squared, or not plus, what am I doing? Times, this would be like x squared times x to the 2k all over, and this will be, plug in k plus 1, we'll get k plus 1 times k factorial times, and then we'll do reciprocal, k factorial on the top, 2 to the k, x to the 2k. Okay, then we cancel. We'll pull out everything that doesn't have to do with k. So we'll pull out a 2x squared. And we don't need the absolute value again because it's squared. And then this will be times limit. Ooh, everything canceled, so this will be 1 all over. Okay, so now we can see this converges always, because that limit, wait, is that right? Did I make a mistake? Let me make sure. Yeah, that's right. Yeah, so this will always converge since this equals 0, so it doesn't matter what x is. This will, when you multiply it, this will always be 0, which will always be less than 1. So this interval of convergence is just negative infinity to infinity. Okay, so here's the bonus question. All right, so we need a third degree Taylor polynomial for this function about x equals 0. Okay, so in general, this is what we need. We need f of 0 plus f prime at 0 times x plus f double prime at 0 times x squared over 2 plus f triple prime 0 times x cubed over 6. Okay, so now we just need all these different derivatives, basically. Okay, so what do they tell us? Okay, portion of the graph of f is shown above, along with the line tangent of the graph of 0. Okay, select derivatives of selected derivatives. Okay, so we have the we need only up to the third derivative, so we don't need this last one even. So f of 0, we need that, and since this is the graph of f of 0 is 3, so we know that. Okay, so f prime of 0. So that's at 0, that's the slope of the tangent line, right? First derivative is slope of tangent line. So we can see the slope of this tangent line, it goes down to right 1. So this is negative 2. That's the slope, so that's the derivative. This will really be minus 2x. Okay, the next derivative at 0 is 3. And the last one, the third derivative at 0, 23 over 2, multiplied by x cubed over 6. Alright, so this is it. So this is like P3. And if we just clean this up, and then get that. Okay, so this next one says write the first three non-zero terms in the Maclaurin series for e to the x, and then write the second degree Taylor polynomial for e to the x times f of x when x equals 0. Okay, so first we'll need our previous f of x. Okay, so that's this here. Oh, wait. Wait, that's not enough. Wait, sorry. Oh yeah, okay, so this this is the third degree Taylor polynomial that is approximating f, right? So if we kept going, we would actually get f if we kept doing more terms, you know, an infinite number of terms, that would give us f exactly, but we at least know that f starts this way, right? Okay, so this is the approximation for f as a Taylor polynomial. And then if we get e to the x, just memorizing this is 1 plus x plus x squared over 2 x cubed over 6. Okay, and then this will be similar to that other one where when you multiply these, so this is, you know, this is basically our f of x that we multiply with these. You technically have to FOIL, but we'll just do, if we want a second degree, we'll just make sure, you know, we won't care about any terms that have exponents that are 3 or greater. Okay, so we definitely can ignore these terms. Now think about if we take this, we could take this and multiply, if we FOIL, multiply it by 1. So e to the x f of x as a Taylor polynomial. This will be So we'll do these 3 times 1. And then we don't need to do this one times x, but we'll do these 2 times x. And then now we don't need to do these 2 times this, but we'll do 3 times x squared over 2. Like that. And this is it. So this will approximate. So now I'll just clean this up. So this and this is 3x squared minus 2x squared. Actually, let's do the constants first. What am I doing? So there's only one constant, that's 3. Okay, done with that. And then as far as the x terms go, we just have those 2. So negative 2x plus 3x is a positive x. Takes care of those. And then 3x squared plus 3x squared over 2 plus 3x squared over 2 is just 3x squared minus 2x squared is just x squared. Okay, and so that's it. First 3 non-zero terms of the Maclaurin series. Right? Okay. Okay. So here's the first part. First 3 non-zero terms of the Maclaurin series for e to the x. And then we did the second degree Taylor polynomial for this. That's what that is.